Hello and welcome to the classes by Mrs. Monisha Nath Paul. Today we are back again with the lesson Congruence of Triangles. Today we are going to do more sums based on the topic congruence. The last videos were based on the topics the explanation of the topic, the sums, the rules. So please go through the previous videos, the links of which have been mentioned in the description box. So we have a sum written on the board. In the given figure, line L is the bisector of angle A and B is any point on L. So you can see an angle over here, and this is the line which is the bisector of this angle A. Okay. Next, BP and BQ are perpendiculars from B to the arms of angle A. So this is angle A and these are the two arms of angle A. Now L is the bisector of angle A. That means this angle and this angle is same. All right. Now from B we are drawing two perpendiculars. We have two perpendiculars drawn, BQ and BP, on the two arms of the angle. We have to show triangle APB, that is APB, that is this triangle, and triangle AQB, this triangle, they are congruent to each other. All right. So these two. Now first we locate what are the what is the condition, or what are the congruent parts that will make the two triangles congruent. First thing is that because it is a right angle triangle, the very first thing that can come in your mind is RHS axiom. So we know that for an RHS, for two triangles to be proving via RHS their congruency, we have to check for the right angle, okay, which is there. We have to check for the hypotenuse. So in this case, we can see AB is the hypotenuse, that is working as a hypotenuse for both the triangles. Also, one of the sides. So we have no mention about the equality of the sides in this figure. Okay, for these two triangles, we have no mention about the sides, the remaining sides being equal in any of the two triangles. So this case is not working over here. So RHS is cancelled. So what else can we do over here? You see 90 degree and 90 degree. That is equal for both the triangles. Second, because this is the bisector, so this angle and this angle, these two angles are equal. So we have two angles. So two angles are there in the story. That means we have two axioms which involves two angles. Either it can be angle side rule, or it can be angle side angle rule. So if it is angle side angle, means included side, that means I have to take AP and AQ. No mention about AQ being equal to AP. So the only possibility is AAS, which means if 90 and this angle, 90 and this angle, this bisected part of this angle and this angle is same, you can see the part AB is common to both. That means I can say angle side. This will be working here. Via this we can establish the congruence of these two triangles. So now going to the working. So in triangle APB and triangle AQB, number one is angle APB is equal to angle AQB, and both of them are equal to 90 degree. Why? Because BP, the reason part, BP is perpendicular to AP and BQ is perpendicular to AQ. So this makes the two angles 90. Okay. BP perpendicular to AP and BQ perpendicular to AQ. Next, angle PAB is equal to angle QAB. Okay, see, naming PAB, second, first, third, PAB. Here also QAB, second, first, third. So PAB equals to QAB. I said following the vertices in the statements part also is a good practice. So try doing that. So when I say P, because this vertex P and this vertex Q will coincide, the A of both will coincide and the B of both will coincide. That means if I say PAB, talking about this angle. So PAB, then corresponding vertices QAB. All right. So what is the reason for this? That is line L is the bisector of angle A. Third, that is AB equals to AB. What is the reason for AB equals to AB? That is the AB is equal to AB is common to both the triangles, common side. All right. So we have got angle, side. Always try mentioning the statements in the order of the rule that you are going to establish. So it becomes for you to cross check while you finish your sum. If you want to cross check your sum, if you write it in this way, it makes your work easier. So we can say therefore triangle APB is congruent to triangle AQB by angle side rule. So you can see the congruence has been established. The next part, the first part of the question is already done. Second, we have to put that proof that B is equidistant. So B is equidistant means I have to prove this is equal to this. So naturally BP is equal to BQ. Quite evident from the proof itself. BP is equal to BQ. What is the reason? CP CT. Okay. So this can be also written in this way, that B is equidistant from the arms of angle A, going by the question. So B is equidistant from the arms of angle A. So with this, we come to the end of the proof. So what did we do here? So whenever you see right angle triangle given to you, don't just think that a right angle triangle means it has to have a proof with RHS axiom. No, it's not like that. You have to see what are the conditions provided to us. Only based on that you can talk about you can establish the congruence. So here, like, this is the very clear example of whatever I said just now. Being a right angle triangle, these two did not follow the RHS rule. They followed the AAS rule. Okay. So always see what criteria you are given in the question. All right. So with this, we have come to the proof that these two triangles are congruent by the AAS rule. Okay. I hope you have understood this sum. So we'll move on to the next problem. Okay, now coming to the next sum. It is given that in the given figure, AB is a line segment. So we have AB as a line segment over here, and P is its midpoint. So P is the midpoint. So that means AP will be equal to BP. D and E are points on the same side of AB. So on this side of AB, we have points E and points D. So D and E are points on the same side of AB such that BAD, so BAD, this angle is equal to ABE. So these two angles are equal. All right. And EPA, so EPA, this angle is equal to DPB, this angle. All right. So we have to show that triangle DAP. So DAP is DAP, this triangle. I'll darken the triangle. This triangle is congruent to EBP. Okay. These two triangles. So triangle DAP is congruent to triangle EBP. Fine. So we'll start with that only. So in triangle DAP and triangle EBP. So it's quite clear from the figure that we have for triangles DAP and triangle EBP, these two angles are same. Now this angle, these two angles, that is angle APE and BPE. These are not parts of the whole parts of the arcs triangle which have to be proved as congruent. So this is, you have to think about it. But AP and BP, these are parts of that triangle. So we have one side same and one angle same. So side and angle is given. So it can be any one of SAS or ASA or AAS. Let's see what is it. Now, if you can see, talking about angle DPA, this part is common to both these triangles. This angle, this part of the angle is common to this angle as well as common to this angle. All right. So if I can do this over here, that is, it is given to you that angle EPA equals to angle DPB. Now, if to both sides I add angle EPD, we can do. So you see from the figure, EPA plus EPD is giving us angle APD, and DPB plus EPD, okay, will give us angle BPE. So you see, we have showed that APD is equal to BPE. All right, now this we will be using in this problem. Number 1, angle A equals to angle B. What is the reason for that? It is given to you that angle BAD equals to angle ABE. It was already given to you, that is BAD, that is this angle, is equal to angle ABE, this angle. So we can write angle A is equal to angle B. All right. Next is AP equals to BP. Following AP is equal to BP. Reason, P is the midpoint of AB, that is given. P is the midpoint of AB. All right. Third is, see, two angles and the side in between them. Thus it is angle side angle rule which we are going to follow over here. Angle APD, okay, APD is equal to BPE. APD means second, third, first. Here it is also BPE. So second, third, first. Okay. 2, 3, 1. Second was vertex, third vertex, first vertex. Here also second vertex, third vertex, first vertex. So APD is equal to BPE. This we will say shown above or proved above. Proved above. All right. Therefore, triangle DAP is congruent to triangle EBP by ASA rule. Now coming to the next part, that is AD is equal to BE. Now AD and BE. Let's see. AD and B. Yes, they are the corresponding parts. So for congruent triangles, we know that corresponding parts are equal. So AD equals to BE. CP, CT. All right. So hence proved. All right. So the question, only this part required a little bit of thinking. That is, this the portions given to you was EPA and DPB. They were equal. So we added angle EPD to both the angles in order to get the angle corresponding angles of the two triangles which had to be proved to be congruent. So we got APD and BPE to be equal. Now this we have used in the problem. So as per the question, we have to talk about, take the triangles DAP and EBP. So EBP, these are the two triangles we are talking about. So first is angle A and angle B is equal because of the given part in the question, that is BAD is equal to ABE. This was given in the question. Next is AP is equal to BP. Okay, so AP and BP are same. What is the reason? P is the midpoint of AB. Next is APD is equal to BPE, which we have proved over here. So APD is equal to BPE, that is proved above. Therefore, we can say triangle DAP is congruent to triangle EBP by what rule? By C, two angles and the included side. So angle, side angle rule. Next, we have to prove AD and BE are congruent. So let's check whether they are the corresponding paths or not. So you see AD and this is BE. Yes, the vertices are falling on each other. A matched with B and D matched with E. So we can say yes, that AD is equal to BE. And what is the reason for that? They are the corresponding parts of the congruent triangles. So CP, CT, hence. Thus we come to the end of the problem here. So two solutions of two problems based on angle side and angle side angle rule have been discussed today. Please go through the video in order to make the concept of congruency clear and complete. Please go through the previous videos in order to have a clear idea of the chapter from the very beginning of itself. Okay, so hope to meet you next day in my upcoming video. But before that, don't forget, if you like the videos, if you like the way I explain, then please do like the channel. Comment your problems, comment your doubts. I would love to attend them. Subscribe the channel and also don't forget to share it with your friends. Okay, so meet you very soon in my next video. Thank you.